What are elliptical planetary orbits? Have you ever wondered how planets travel around the Sun? The answer lies in something called elliptical planetary orbits. These orbits are not perfect circles. Instead, they have an oval shape. This means that the distance between a planet and the Sun changes as the planet moves along its path. The concept of elliptical orbits was introduced by Johannes Kepler, an important figure during the Renaissance period in Europe. Kepler formulated 3 laws of planetary motion, with his first law stating that every planet moves in an elliptical orbit with the Sun at one focus. This was a major shift from earlier beliefs that planets moved in circular paths with the Sun at the center. An ellipse has 2 focal points, and the Sun occupies one of these points in the case of planetary orbits. The closest point in the orbit to the Sun is called the perihelion, while the farthest point is known as the aphelion. The shape of the ellipse is described by a number called eccentricity, which ranges from 0 to 1. A value of 0 means the orbit is a perfect circle, while values closer to 1 indicate a more elongated shape. Most planets in our solar system have low eccentricities, meaning their orbits are nearly circular. Kepler's discoveries were based on careful observations and mathematical calculations, particularly those of Mars, using data collected by Tycho Brahe. This understanding of elliptical orbits allowed for more accurate predictions of where planets would be in the sky. Elliptical orbits also explain why a planet's speed changes as it travels around the Sun. According to Kepler's second law, a planet moves faster when it is near the perihelion and slower when it is near the aphelion. This variation in speed occurs because the gravitational force between the planet and the Sun changes with distance. Kepler's laws were fundamental to the scientific revolution in Europe. They laid the groundwork for Isaac Newton's law of universal gravitation, which explained why planets follow these elliptical paths. In essence, elliptical planetary orbits are oval-shaped paths with the Sun at one focus. This discovery transformed astronomy during the Renaissance, moving away from the circular orbit models of the past. It allowed for a more precise understanding of how planets move, influencing the development of modern physics and astronomy.